Hi, morning. I'm going to share with you about Dr. Wu Chien-Shiung, the First Lady of Physics. Dr. Wu was nicknamed the Chinese Madame Curie. She was the recipient of the first Wolf Prize in Physics in 1978 and being a woman physicist. And she was the first woman to receive an honorary doctorate from Princeton University, very prestigious university in the United States of America. She was also the first female president of the American Physical Society, and she is an outstanding and a leading experimental physicist of the 20th century. Now, Wu Jianxiong has a masculine name, born 1912, left us in 1997. She's an iconic experimental physicist. And the new postage stamp of the United States Postal Service in February 11, 2020, honor her with a postage stamp, Chien-Shiung Wu, nuclear physicist. Now, in the past, great physicists, Nobel laureates were honored with stamps. You could recognize some of them: Albert Einstein, Enrico Fermi. In the top is Galileo Galilei, Raman, Maxwell, and the lower left, Röntgen. And so with many, you have Yukawa, Tomonaka top. And then on the right is the Chien-Shiung. We'll talk more about him later. And then the Bragg's father and the son, uh, and Max Planck as well on the lower left. Majority were men. However, there were a small number of women physicists. Some went on to win the Nobel Prize, like Madame Marie Curie, and then also the son-in-law and daughter, Juliet and Irene, and also you see you have the Marie Mayer and Liz as well. And the center is Chien-Shiung Wu, the latest addition in the Hall of Fame amongst the women physicists in the world. Let me share with you a little bit about Wu's brief life journey. She was born and raised in Taichung, in the Jiangsu province in China. There's a hometown. See the picture of what it looks like today. Then she was educated at Mingde School, the primary school, and then went on to Suzhou Women's Normal School number 2, and then National Central University in Nanjing, and then Zhejiang University. So from young, she had developed interests in maths and physics and went on to excel in science subjects. And then she recommended to go to US to further her study. And it's a pretty long journey, tough experience being a woman and coming from China as well. So she finally obtained a PhD from University of California, Berkeley, Belt and Princeton University, but eventually spent a majority of her career at the Columbia University. And this is the current the Mingde School. There's a statue of Wu in the campus there. The Mingde School still operated today. So there's a very brief history of Wu's upbringing and went to United States. And you see that it's a very elegant lady, honored by lots of institutions. Here is by the Smithsonian Institution in the United States. Now she rose to fame, and the Manhattan Project was started just before the Second World War. You know about the United States had the plan to develop an atomic bomb as a form of deterrent to the aggressive invasion by Japan and Germany. So Wu helped to develop a process that used gaseous diffusion to isolate radioactive uranium isotopes. And her initial experiments became the basis of a huge separation efforts at the Oak Ridge facility at Tennessee. And eventually, she and her team developed the fuel for the bomb. And that is important. So then the community of scientists began to take notice of her experimental skills. Her rose to fame was the parity conservation. That was the weak interaction, the beta decay. It was believed that in the beta decay, the neutrons convert to proton emission of electron. But it's more than that. There is the emission of the anti-neutrino for the conservation of momentum. And two great theoretical physicists, Sung-Dao Lee and Chien-Shiung, in 1956, they realized that there was no evidence to show that the parity was conserved in the weak interaction. And they postulated that the symmetry may not be preserved by the weak force. And they were interested to have the experiment designed and performed to prove their theory. And that was the concept, the design of the experiment. On the left, assume that this cobalt-60 in a solenoid to have polarization, and if symmetry is conserved on the mirror image on the right, you will expect the beta decay direction is pointing upward, same as the original arrangement. However, if the symmetry is not preserved, the beta decay direction is closer downward. So that was the concept, and they were looking for the great experimental physicists to perform this experiment, and it landed with Chien-Shiung Wu and her team. And this is her classic experiment, and she had a team of low temperature physicists and nuclear physicists to design. The idea is to cool down the cobalt-60 nuclei and to measure or detect the direction of the gamma ray polarization, and that is an indication of the beta decay direction as well. A very clever experiment, with a lot of smart design and skill in low temperature physics, and also measurement technique as well. So they cool it down and then slightly increase the temperature, and to show that if that polarization direction was intact, and also prove that symmetry is being preserved or not. So they published this landmark paper, the experimental test of parity conservation in beta decay, in Physical Review, February 15, 1957. And this is revolutionary to show that the parity is not conserved, which has been long held for decades before that. So that It's created worldwide excitement, and many still couldn't believe that that could be true. And that is the snapshot of the paper that they published, the seminal paper in Physical Review. It is a photo of Sung Dao Lee and Chien-Shiung. They both went on to win the Nobel Prize for Physics for their beta decay theory. Incidentally, Chien-Shiung served as the external examiner at the physics department, University of Malaya, 1974, when I was there in the honors year. So we listened to his talk, and he was a very tough examiner as well. And during that year, none of us received the first class honors. It's quite interesting to be proud that Chien-Shiung was the external examiner for the honors year exam. However, it is quite sad that Chien-Shiung Wu was overlooked for the Nobel Prize for various reasons, and there are a lot of papers being published, various speculations and others. Well, she deserved to be honored because of a groundbreaking experiment to prove the beta decay non-conservation of parity. Some reflection on Wu's life and contribution in physics. Her PhD advisor, Ernest O. Lawrence, described her as the most talented female experimental physicist he had ever known, and that she would make any laboratory shine. And Emilio Segre, both of these Nobel laureates, commented that Wu was a popular student who was talented and quite attractive to many males. It's a good compliment, isn't it? You look at the photo, yeah, indeed, she was not only talented but most beautiful experimental physicist, as commented by another Nobel laureate, Luis Alvarez, and that he got to know this graduate student, share the same room as him, and she had a nickname called Gigi when she was doing her PhD in Berkeley. She's honored by various books, and these were two outstanding ones. On the left, by picture book 2019, is Queen of Physics, is a cartoon-like picture book. And then the one, Madame Wu Chien-Shiung, published by the World Scientific. It was written in Mandarin. It was translated into English in 2013. So encourage you to get out these books and read. It's a very interesting life stories about Chien-Shiung Wu. So her story is one of passion of learning and a courage and persistence to succeed in a society and a professional field that is physics. At that time, environment was rather hostile. Being a woman and coming from China to a totally new environment, and physics was a domain of males. So she was struggling to be recognized by her peers. So she has various ups and downs. However, courageous and persistent effort led to her success. And she also encountered various forms of prejudices, gender as well as ethnic origin. After retirement, her later life, she was an advocate for human rights, very active in that, and she very spoke up against gender discrimination, as she had experienced when she moved to the United States and different universities then. And she was also active in promoting STEM education for all, promoting science, technology, engineering, and mathematics. So we are grateful to Dr. Wu for her exemplary life and her courage, stellar contribution to physics. That is tremendous contribution to physics and science for all. And we continue to be inspired by Dr. Chien-Shiung Wu.